Hello and welcome back to Evening Rust. I'm edA-qa mort-ora-y and we're here to conquer the world with Rust, or at least conquer coding game. Today we are going to be playing Code4Life, which is a relatively new one. We didn't get to it as soon as it came out, but a lot of our friends are there and we're going to check it out. But to get things started, as always, we're going to jump over and do a Clash of Code, and we'll just keep introducing myself as it goes. Hello, edA-qa. Inc. L12. Welcome to the show. I hope you enjoy it. Have you seen you around here before? I'm not sure. Anyways, we have Clash of Code. What we do is we have one of three contests. We have either do it the fastest, do it golf, or do reverse engineering. As we've seen previously, Rust does not perform too well in golf, except when people don't understand the question, and then if we understand it, we do relatively well. And we're getting quite high up there. Thanks a lot, edA-qa. Glad you're enjoying the shows. We'll keep trying to make them interesting. I was on a bit of vacation up until today, so I wasn't here on Thursday or Friday or Saturday. I was out doing some cross-country skiing in the snow where it was cold, and Rust is not as much cold, but we'll see where we get to now. And we're just waiting for 4 other people to join. Hopefully we get a full 8. As I said, we tend to do better when we have 8 people here as opposed to just 4. I installed a new version of Rust today. We'll see how that works. I use the Rust Up util. It makes it easy, but I'm not too happy with where it installs it. It installs it in my home directory, and I absolutely hate having binaries installed in my home directory, as it makes backups a real pain in the ass. So I wish it didn't install it there, and I couldn't find any option to install later. But apparently it installs a bunch of stuff over in Visual Studio, which we're going to figure out how to use at some point during the show, like getting to the line number, or looking up autocomplete and stuff for Rust. We'll see how that works a bit later. Doing this one here, we don't use the external editor because it's too fast, or we don't have enough time to set it up. But we will use that definitely in the Code4Life competition, and we'll get to that really soon. And it's taking a while for people to sign up here. So what else can I say has happened last time? Let's open another window. We've managed to slip into the master rank here. This is very important here, or not very important, but it's very interesting. So we're ranked 2, 3, 4, 7th. And now you see we barely slipped in. This is last week, and the show we're slipping a bit, right? We were a bit higher, and we're slowly slipping. So we're hoping if we do one more competition today, we should boost it up a bit to be safely in that rank. And our goal, our next term goal, is to let's first off break 2,000, but I think we can break 1,000. If not this month, the next month. Let's hopefully we can break it next month. So we could do, this is only for competition. The achievements are all for practice, if we do practice, but next month the competition starts, and that should definitely give us some points here in the contest, because we have 0, and we can't get any until one of the contests actually starts. Clash of Code, I'm doing relatively well in, and you have a lot of points. It seems to be highly valued. The multiplayer, we've done a few. Uh-oh, I gotta go start. Alright, so we're gonna start this. I don't know why it started earlier, it's not full, but let's see. Alright, so we have to solve this fast pile. Must perform a binary and a 2 binary numbers given through the standard input and print the result of the standard output. Warning, the number of binary digits must remain the same. 2 binary numbers, so they're both binary numbers. And 1 and 2, okay, and it has to be the same house. Okay, so we have the 2 binary numbers. This is going to be a bit challenge for I in 1.lang. Actually, we could have left that in, because I don't know if we're going to be able to do this too much. We'll just print line here. It's a bit challenging here in Rust, because what we have to do is we have to get the character for it. So let's see, 1 equal N1 I. I don't know if it's going to let us do this because it's a string. This is the biggest challenge here. And so we'll compile this first of all and see if we can at least get that. And usize, oh yeah, 0 dot dot. Yeah, so we're going to have a problem here with string that we shouldn't probably do it to string. We want to trim right. We don't need to string. Let's just do collect. Collect as vector char instead. Hello Avarice, we're just doing this competition. The kite to code here, and we're just trying to figure out what's the quickest way to collect things as characters in Rust. because that's the biggest issue here. Collect. Okay, we screwed up the collect here. Alright, I forgot the collect syntax on line 23. What is the line syntax? Let's just say collect. Can I collect this? Okay, so we're automatically going slow here. Okay, great. So we have trim right. .characters.collect. Let's do .chars.collect. Let's collect all of them. So we don't know the length of that, and I think it's because we had to do a vector here. Vec of char. I'm surprised somebody isn't done yet. This seems like something you do relatively quickly. Okay, we found nothing, so that's good. We have the characters. So, and it does a binary and, okay, if C1 equals 1 and C2 equals 1, then we can print 1. This is a vector. Otherwise, we print 0, and let's see what happens. All right, that looks good. Bit slow. We had a bit problem with the collect. I'm still not good enough with the collecting. Avarice, thank you very much. Our lag. If we didn't have this Twitch lag, we would have had that. Yeah, I don't know, a few seconds earlier. And we're pretty good at 100%. So we should be doing pretty good in this contest here. And somebody slipped in right behind us. And this is challenging. I mean, just to remember, like, the small things. If you know a language better, let's submit this code. It's not very good Rust code, but I'm sure there's a better way to do it. And let's see what Python 3 did. And so they took a slightly different approach. They compared the two and output that one if it's equal. So that was just the quickest way I thought of it. And see, doing the ranges are a little bit easier in Python. You just do the input, right? And this makes it a lot simpler when doing these things, that you just take the input and you can iterate over a string. It's a bit of a challenge in Rust that you can't just iterate or index into a string. I find it's actually a bit unfortunate in the language, because to me a string is a collection of chars. And so to me it doesn't help the idea that your string isn't a collection of chars and you always have to do this collecting. That's okay. For these competitions, for coding, it may not be a big deal. Let's see what the JavaScript guy did. And he did the same approach we took. If he said they're both 1, 1, then otherwise 0, and he just printed it out in the end. And these guys accumulated a string. I would actually prefer to accumulate a string, but I'm always worried that I don't get the syntax right. It's quicker for me to just print it out. And I'm going to do a quick check at my temperature on my computer. The fans seem to be going wild. I don't know why. It's not very hot. Wow. What is code? What is this thing here? What the hell is that? What the hell is code, and why is it taking so long? That's weird. Is it this? No. What the hell is this code program? I don't know. It's code. Code is vs code. Okay, yeah. So it's. Why on earth is I killed code and it's still there. This is annoying. So that would be why my fan is going crazy, because code is taking up all this time. But why is code still running? Kill all. Let's just kill code. Okay, code is gone. OBS is taking a lot. Yes, the streaming is taking a lot. But this machine, I have 8 cores on the machine, so I'm not really concerned about running out of space. It just, when it starts warming up and I can hear it, but the fact that Visual Studio is taking so much. Alright, and it's already calmed down a little bit. So let's start at Visual Studio again. Alright, so this shouldn't be taking much. Why was code taking up so much before? Code is now sitting away, so I don't know what happened to code. It was doing some updates before, and it must have got stuck somewhere. But okay, we got rid of that now. happy, so it should at least be a little bit quieter, but goes a little bit slower. It has 2 of them now. It's still doing a lot. It shouldn't show up. I mean, it's oh well. I don't worry about that. The main problem is gone. These other guys aren't done yet. They gave up, or I'm never sure why. And it'd be nice to see what solution they come up with in the end. But let's just hop over to the actual thing we want to do. And I'm just reading what Memoriam wrote. Choosing where to install. Perfect. I'll redo it again later. I'm just going to remove it and... Alright, I'll install it somewhere else later because it is fairly large and it is my home directory, and I said the main reason I don't like stuff in my home directory is because it makes my backups a lot bigger. So I have to do the backups and just adds needless cruft to the backup, and I don't like it there. Okay, so let's go over here. We want to go into compete today. Code4Life. Conditions. So it tells us what will we learn. We're going to learn conditions. Now this is a little bit weird, this conditions thing, and it has a link. I'm very curious as to what it says under conditions. Let's read what conditions are. Does it mean like if statements? It does mean if statements. Okay. At this point, I think we've got some if conditions down, except Rust exposes a lot of fun ways to do if conditions. I mean, it has like the matching, which we prefer. So we're going to learn conditions. And the other thing we're going to learn is a state machine. And we haven't done one of these in Rust, but they're very similar. I'm hoping they're very similar. We've had states before, but not an actual state machine. And we'll see how it actually works. The finite state machine... We just go to different states, and I'm curious how this works because the other competitions they talk about like actual AI strategies in terms of min-max, optimization, reduction, and this one doesn't mention that. But obviously there must be an AI strategy here, otherwise we wouldn't have the ranking. As we can see, Euler Schitzal, he's up really nice high. Our friend Nkoyan here is up to 27th, and a few of the other friends we followed here. With Dwarfy, the guy that we've been trying to beat with the Code Golf the whole time in Rust, who's doing well. And Jasper's the guy that writes our tool, which I just closed. We're going to have to open it up again. He wrote this tool for us to connect to external editor, which we'll do. Contest, so this just says the contest winner used a min-max, although they didn't link it. Okay, yeah. So that would make sense. So again, the min-max is, when we get there, I mean, our first step is going to be just implement this so it does anything. Like, let's just see that it works. And the min-max is basically a strategy where when you're stepping through and consider what the other guy does, you try to imagine, how is he going to mess with me the most? And let's anticipate the worst move for me and counteract that worst move. And it minimizes your losses, but it has the... And if it works to get first, that's great. That means we can follow it. It usually has at the cost of reducing your maximum, but min-max tends to work because it doesn't require you to think too much about predicting what the other player does. You can just sort of say, well, this is the best thing or the worst thing you can do, and let's plan for that, as opposed to actually having to guess what he's going to do and outguess him. But that's another option. Let's just... And I see Euler Schitzal is actually in our demo video here. It's our little frog guy. The Hypnotoad. Hypnotoad's right here. So it's nice that you made it, you know, your celebrity on the learning board. It's very cool. So let's just join it. Let's see what this thing has to say. And so apparently enough people qualify for Legend, which is really good that they're going to be opening a Legend, because it means all the people in the top gold are going to shift over to Legend and eventually give us a chance to get up there. Today we're just hoping to get out of the Wood League into the Bronze, maybe Silver, depending on how our strategy ends up working here. Okay. This is a league-based puzzle. Got it. As a developer at Roche, your work can directly impact the future of science, healthcare, and quality of life for patients worldwide. In this game, a Roche complex is equipped with a state-of-the-art robotic drone capable of interfacing with all the types of software, from software used to diagnose disease at the molecular level to the finding of new medicines. However, the robot needs an algorithm to optimize this process, and for that, Roche needs you. Please note, this is a game and does not reflect reality. Okay, so somebody had to lawyer up over there and actually added this. I mean, although I actually would love to have some lab somewhere running with little robots and we could actually program it and then we save humanity, but okay, it's just really weird they wrote that. So Code4Life is a special contest. Don't be surprised or deterred if it takes you longer than usual to have your first AI working. It's totally normal. Okay? You can view this first part as solving a medium puzzle, then it's a classic multiplayer league game puzzle. Now this kind of, it's kind of shocking here that they say this, because when we solved a lot of the medium puzzles or the puzzles as opposed to multiplayer, what you're thinking about is actually very different. Do you want to solve the puzzle or do you actually want to go multiplayer? So because they mentioned this, we're just really going to approach the way, let's just solve the puzzle. Let's get through the Wood League, let's just solve it, let's just make it work, and forget about the multiplayer aspect originally. We can get to that later. Now let's go through the rules here, and a game is played with 2 players, and I wonder if that goes up in the future. I don't know. If any of you in the leagues, can you tell me if there's more players in the future? That would help my code structure originally, but I think I've always planned for multiple players anyways. The complex is composed of 3 modules named Diagnosis, Molecules, and Laboratory. The robots can transfer two types of items from and to the modules: sample data files and molecules. It's always, thank you very much, always 1 versus 1. I ask this because when I do an interview question, I tell people to refactor a game from 2 to 3 players, and if you know it's going to be n players to start with, you actually code differently. But if it's 1 versus 1, that might simplify it a bit for us. In a nutshell, you have to optimize your robot movements too. Collect sample data files from the cloud at the Diagnosis module. Gather required molecules from medicine at the Medicals module. Produce the medicines at the Laboratory module and collect your health points. Alright, so we have health points. So we collect, gather, and produce. Collect, gather, and produce. That's what the little video is showing. It's got to be more complex than that, though. Each player has 1 robot. Both robots have the same starting position. A robot can carry up to 3 sample data files and 10 molecules. Oh, okay, here's where the optimization aspect comes from. So, go to. So we can go to. Once the robot is at a module's interface, it can connect with the connect command. This will have a different effect for each module. So we're going to go to connect, go to connect. A sample data file is an item representing all known data on the tissue sample collected from an untreated patient. Researching the sample may ultimately lead to the production of medicine to prolong the lives of all patients with the same ailments. A sample data associated with the list of molecules needed to produce the medicine for that sample. A sample will grant you a variable number of health points when you research it. A molecule can be one of 5 types: A, B, C, D, or E. Thank goodness they simplified that and didn't give us some sort of atomic structure or chemical formula. That would be kind of annoying. Connecting to this module with Connect ID will transfer the robot sample file identified by ID from the cloud of the Diagnosis machine to your robot. Oh, fun. The molecule distribution machine. Connecting to this module with Connect Type, where type is one of the molecule types, will transfer an available module to a robot of the desired type. Perfect. To use this module, the player's robot must be carrying a sample data file as well as the required amount of molecules for producing that sample's medicine. Connecting to the module 1, where ID is the identifier of a sample data the player can research, will have several effects. The sample data ID as well as associated molecules are removed from play. The player scores as many points as the sample's health points. The player acquires molecule expertise. The robot will need 1 less molecule of the type specified as sample for producing all subsequent medicines. Alright, so you can already see this building up, this horrible optimization problem here. We have a lot of optimization points here, is that you can carry 3 of these sample data files. You can only carry 10 molecules. And this is in a sequence, you have to do it in a sequence. But every time you research one, you can acquire 1 less module for the same type of that file. Now what I'm unclear was where the sample files come from, and that cling was just that we had a score in the other one. So there's lots of things to optimize, and so this will be really interesting in the end. And you can already see just getting the basic done is going to be a little bit of a challenge. Okay, in victory, your robot has scored the most health points after 200 turns, or once a player has had at least 170 points. What I'm guessing, and I'm guessing Oilshitall can confirm, is that in the Gold League, does it ever run out of turns, or do people always reach 170? My guess is that people reaching 170, that just makes it go faster. And that actually puts a stress point in. Okay, now we have the difficult part. Wow, let's actually start up the external code editor and just jump over to that right away and see if we can get that working, because sometimes just looking at how it's parsing it works right away. So we're going to have to create a new file. In bronze, the rules are changed. Always 200 turns, no matter of the score. Alright, interesting. I wonder why they make that change. Why would they say 170? That's just weird. I don't know why they'd say 170 if not 200. 5 each side you can block. Oh, great. So another blocking point. Wow, that's a lot to do. I'm surprised the Minimax works then. You would suspect that an algorithm that actually predicts what the other guy is doing would make the most sense. So if you can see what ID he's doing to take away his modules to block, which would technically not be Minimax, I think. That would be a different one. But I guess, depending on your scoring. Okay, I'm going to create this directory first. We're going to cargo init something somewhere. Source, coding game, cargo init. Is it new? Cargo new bin. What do we call this? Code4Life? Code4Life. Alright, see, Code4Life. What do we have in here? It didn't create my Git file again. It stopped creating this at one point. We lost the settings. And even though somebody told me how to set it and rerun it, it's just stopped creating the settings for it now. I don't know why. Let's just copy it from thor.gitignore. That's all we really need is the gitignore, nothing more. So we have this directory, everything here, we need the targets. That's just to clean it up. And now let's configure this. Oh, back to settings. That's no one. Select the file, /source, /coding game. I'm still uncertain about publishing all this stuff to get code. I'm going to ask the guys at Coding Game first. We're not doing too well on most of the contests. I mean, we're doing okay, but I'm just going to confirm that it's okay to publish all this code. I think all the contests should be not a problem because we publish that anyways. It's view there. But these multiplayer ones, we don't know. I don't care if it creates competition for itself. I don't think anybody's going to come in and steal the Rust stuff from us. And that's not the point of the show anyways. And the guys that are doing really well, I think, are still going to beat us, even if we share. Okay, so we're going to download the first one here. There we go. And let's see what we have. And open this up. And, well, let's actually just run it once first, just to see what the graphics look like. And we're not doing anything, so we're always going to sit around like an idiot, but let's just see what the graphics look like. That's always kind of fun. I hope you can see it over there. You're going to be clipped a bit, but so this is probably my robot doing nothing. And so this is computer, and he's doing the very basic strategy, back and forth here, and these are always sort of IDs, interesting. Okay, and so I'm assuming this comes in a further one. Alright, so we don't have to look at this much longer, so until we start emitting something, our robot's going to do absolutely nothing. And you collect points very slowly here, so I'm surprised you reach. At this rate, I'm surprised you reach 170, unless it speeds up a lot. Alright, so let that run. Let's go over to our code here, and let's open this up. And nothing's ever in the right place. I created this evening rush directory, then I create another one. I don't know why I have two of them. I'm going to have to merge them together. Code4Life, source. Alright, so we have all these useless things at the top. Print error we don't ever need because it's eprint. Parse input we'll leave for there. And this has a lot of stuff to print here. A lot of stuff with storage store. Wow. So we're going to have a lot of stuff we have to parse out of this thing. And we'll just pause this now, save ourselves some CPU time. Always 0, and do not remove for the next leak. So we remove 0. We have a line that we ignore. And what we've been doing in the past is we've been creating a state structure. And we don't have anything in it, but we're going to implement it, and we'll just follow it the same way, implement state. And we're going to have something to create a new one. We don't know what this is yet, but it creates a state. I don't know why it's capitalizing on me. That might be RLS start. What is RLS? I saw it starting, I just clicked yes to install it. I guess that's something to do with the language thing. And Is that possibly what's taking all the CPU? Does it have to load a lot of stuff the first time? So I think we can just create a state like this, and we don't have anything initialized. Okay. Okay. So maybe it's starting something. Okay, we'll see what happens there. Memorials now export on RLS and everything Visual Code and Rust related. So if we have problems, we'll ask you. Okay, input for one game turn. This is a bit weird. What is this that it's importing? I'm getting confused on what it's importing here originally, because it talks about a game turn here, and it says 12 integers, but then it has this stuff here, project count. So it's definitely reading something before the game loop. I'm trying to figure out what it's reading before the game loop, because we have to read this in first. There's 5 integers, and line 1 always 0. Ignore this for league and do not remove for the next leagues. Aha, that's this stuff here. It's going to say this is always 0. So whatever this is, this has to do with something in the next league, so we're not using it here, which kind of makes it hard to abstract into the state. But what we actually have is we're going to assume this is part of the state creation. And so we'll actually, instead of creating new state here, we're going to create function load state standard in. We can make a long name because we don't care, and we'll put all this junk in there. We don't know what it does yet, but we're just going to stick it all in there, and we're just going to completely ignore all of it, and we're just going to return an empty state in the end probably, and we'll get rid of new. And I'm abstracting this just to keep our main loop clear. So now we have a let mut state equals state load state standard. I could probably get rid of the load state here. It's already in the name. I just forgot about that. Load state load standard in, and that loads it from the standard in. Okay. This is the first time I've ever started RLS. So Avarice mentions it shouldn't take this long to start. Maybe it has to do something at the first time that it loads and initializes, because I've never run it before, and I'm guessing that the code is now taking a ton of time again. Code is now taking 135% CPU, 100%. So that's kind of distressing, it's taking so much, but we're going to let it run for a while. As I say, my CPU can burn hot for a while. I have 8 cores. It shouldn't slow us down in any fashion. And my temperature's still only 63 degrees. I cleaned out the fan a couple weeks ago, so it should be fine. And if it goes all evening with it, then I'll notice there's a problem. But otherwise, let's just ignore it for now. So in the game loop, we have this stuff, and I don't know what template they used to emit it, but oh my, look at this stuff. We're going to have to clean this up some way. So what we have is we're going to have a function here, function read turn, I guess. Read turn. And let's move this all into here. And we'll start to figure out what it's reading here. We don't know what all this stuff is. And return. And so this is a loop here. This is going to be state.readTurn. And then we're going to play the turn. So the main code from all this stuff always looks the same. We read the turn, then we play the turn. And I'm going to put it into normal human formatting, which Visual Code doesn't like, but that's okay. And I have to change this to appropriate indentation. There we go. And so from the turn, we're going to start figuring out what these are for, reduce that again. This is always the longest part, and probably the least interesting part is just deciphering the input here. Target module where the player is. For each player, one line, 12 in one string followed by 12 in one string. So I guess the string is the first one. Let me check. The first one is a string target. Okay, got it. And the ETA is, we ignore it. The score, the player's number of health points. Okay, good. So that's just a score. And just a flavor. Number of molecules held by the player for each molecule type. We'll wrap that into 5. And we have expertise, which says ignore. We'll do it. Next line. Okay, so we have that for 2 players. It keeps going to the wrong place. And this 2 is the player count, just hard-coded. We have 2 players. So that's fine. Let's start reading that. We're going to have a state player, and we're going to have a player here, an implementation of a player, and we're probably just going to create a new one here, new player. If you're new to us and watching this for the first time, if you're not just Rust, it separates its data structures from its implementation. It's using a trait-based system. You're not going to see a lot of the purpose in the initial setup, why it's there, but as we implement traits, if we implement traits, it'll become more apparent why it does it that way. And we're going to have an enum, and I've forgotten how to do enums. Enum module. And there's a bunch of modules here, and diagnosis, molecules. And you could just store this as a string, but that's not a nice way to do it because we want to actually read this in laboratory. And there's probably another one in the video, but we don't have to put it yet, so laboratory. So each player has a, where are they, where, and this is a module. And so this is player. Modules don't have defaults, I guess, and the module will be module.diagnosis is where they start. Module : diagnosis, that's how they use statics. And we're going to have a static somewhere which converts this to a diagnosis. And that's the static bit here. Now let's just focus on that a little bit here. So the state is going to have players. And I think I can do this in Rust. Say it's a fixed length of 2, so it has 2 players. And the players are going to be vec how do I create 2 players? How do I create a fixed set of 2 player vectors? Anybody know how to do that? So it's something size 2. But it's not copying anything. These are not copyable. So this would be like hash something derive. I'm going to open up another file so I can reference some of the stuff in it. Thor had stuff in it. I'm just looking at this 1.6. Oh no, that was my minimized. That was a bad one to open. Was reference. And actually, maybe I have it in the cheat sheet. I've not been updating my cheat sheet a lot, which is really sad because there it is. Derive. Derive debug, and I don't know if it has a default, and it probably doesn't. So it probably doesn't have a clone, so I just don't know how to create these 2 people here. So knowing that, I'm just going to stick this. I guess that would work with just we're just going to say just make it derive copy and then just let it copy. And then this will have to be copy as well. It's probably not a bad idea anyways, because I'm guessing when we start getting to the strategy aspect, we might want to start cloning these states. And so we're probably going to clone in here as well. One of these implies the other, but I don't remember which one it is. And so the player is new to go clone company where. And so let's just do player new down here. Player new can create a new player, and we'll just forget about that for now. So we're loading it as creates the players, and it has a diagnosis module. And the first thing we need to do is input this module, and this is for each player. 0, 2. Yeah, let's leave it hard. Okay, I don't like. What did I close that other file for again? That was stupid. I don't like hard-coded values, even if they are never change. Oh, that works. I never considered the so vintage scores. We can put a comma. I've never actually considered putting a comma. I've only ever seen the semicolon notation. So Labyrinth. Let's take out Labyrinth. I had an enum in here somewhere. Not an enum. I had a global. There they are. Const. That's what I want. Const. Keep forgetting const. We'll say useSize, though again, I don't like using useSize for such things. But we can do it this way, useSize. And like I say, even though that doesn't change, I really dislike having magic numbers in code. And you should as well, because saying 0 dot dot num players just tells the next person a lot more than saying 0 dot dot 2. Because 0 dot dot 2 says like, what do you mean 2? Where is this 2 coming from? Whereas a range of 0 to num players says, okay, there's a number of players, it's for every player. It's just so much clearer. Even if the number never going to change, it's just clear to have a constant. I think we'll just keep cloning the same one here for now, because our initial setup for the player makes no difference, because we're just going to be overwriting everything anyways. And our RLS is still starting up, which is kind of annoying, but we'll see what happens with that. Okay, so we target is a target, and so we're going to see returns. This has to be an add self. We've got our self. Let player equals self dot players I. So average is saying we have to intersect 6 player. How does it know how to call new though? Like if I take this out. Oh, you mean up here? Up here I have to initialize it. Really? What does that mean though then? Do I have to put the full initialization or just the player name? Hello, Buddha. I don't think we've seen you before. You need the default value. Okay, then. Perfect. Default just a time. Now I'm confused. I don't know which one to take now. Okay, just that. Just player. Well, I don't have a default yet because I have a new, but I guess this could easily be default instead. Uh-oh. Our RLS thing crashed. Extension host. Let's restart it. Okay. Let's get back to, let's keep going. Once it compiles, we'll figure out if I have the exact correct syntax of what we have to do there. I'm not so concerned. Let's decode the rest of the stuff here. So we have a player, and we have a target, and let's say player dot target is actually where they're going or where they are. Module where the player is. Okay. So player dot where. Actually, let's keep it calling target because that's what they call it in the program. Although it's really weird to call it target because it's not really what it is. And we're going to match this here, match to string. And we have, keeps tabbing to the wrong place. what we have are diagnosis, module diagnosis. There's really no way to simplify the stuff that I know so far. It comes up in a lot of languages. In C++, I would just typically use a macro to do this type of stuff. Molecule, laboratory. Oh, I spelled that horribly wrong. Sorry about that. Laboratory. Hey, let's use autocomplete. See if it actually works. Laboratory. Now, I really don't know what to do on the default case. It's not supposed to happen. And let's try using this panic syntax. I've never used it before. Rust panic. It's supposed to do something fun. Panic. Just tell me to panic. Panic, panic. Ah. It's probably, yeah, there might be. I mean, panic. Alright, we'll do that. Unknown. There probably is a module that does this. Then again, there might not be, because this type of duplication is what I often call, it's called incidental duplication. And incidental duplication is a redundancy that it just so happens that diagnosis is the exact same spelling here. The input, for all we know, could have had this. The input could have been this, in which case it doesn't line up correctly. And so this type of redundancy is not necessarily a bad redundancy, because it just so happens our internal names line up exactly except for the casing. Unimplemented. Unimplemented sounds like reasonable, but in this case I'm actually going to panic because it's unknown. It's not just unimplemented, it shouldn't be there. If it shows up in the code, it means something's gone wrong. It's not just an unimplemented bit, although we actually know in the future version we're going to have to implement it. So I'll stick with panic for now. Don't want to learn too much in one episode. Okay, so we'll just panic, and I think that works. In the ETA, we're just going to ignore. And the score, so player.score equals... And we're going to make no attempt to clean up all this parsing nonsense. I mean, to use a better one, when we do the golf stuff, we really go through here and really try to clean this up. But actually, the storage are going to clean up a little bit, but we need a score now. So the current thing is we need a score, and we need a score. It's an I-32. And this is really pointing towards that, you know, maybe we should have a default now, so we can just live with a default in all of these instead. But then module needs a default, so I don't know. Let's see where I go first. There's also unreachable. Okay, good to memorize. I think unreachable is also technically not correct here because it's based on variable input, so this could actually be reached. It shouldn't be reached, but it is technically. Unreachable I reserve for cases where, like, if you have a match statement and they all have return statements and they cover all paths, and the thing after it should be unreachable. Okay. Now, so player.storage, what I'd like to do here is somehow do a take. How can we possibly do that? There must be a way in Rust, but let's cover the things first. Is that there's only 5, so let's see, first of all, let's check how many. There's 5 of each thing always. 5, where's the number? I'm just reading something, expertise. So we'll put that up here. Const molecule types. The use sizes equals 5. There's 5 molecule types. And the player has to have a size for each of them, and they have a store. And this is again it's getting really weird here how I do this. Can I put a 0 here to put an I-32? And this is num molecule types. And expertise also has the same thing. I32, so it is I32. That's a really weird syntax. Don't have the I32. Okay, so I32, I32. So this player down here is also just be player, okay? What is the expertise? We don't actually know yet. Expertise is possibly the same number. Expertise types. We don't know if those are actually the same. It doesn't explain what they are yet, so we'll just do it this way. Num expertise types. And the store, again, we should probably default all of these. Let's just do this, default. We need to implement a default here, though. I forget how to implement the default. We implemented it somewhere before. Did we implement it somewhere? Default. We implemented a 0.2, but we have a special type. So what we need to do is we need to learn how to implement a default on a enum. I think we did that before, but I forget where. So we need to implement the default for this enum. Impl module default. I need the syntax for this. We'll look it up right away. Because what I like to just do here is say player. So I don't have to manually implement all of this. We just need a module. We need to say what the default is. And I'm guessing this is function like something like this. Function default. Implement default for module. And this becomes module diagnosis. We don't really care. It's just going to be ignored. But it needs to have something. So that's our default. So we implemented that. Self. Where should I be using self? So Buddha says I should be using self as better practice. You mean here? We've never seen that before. All the examples I've seen. Capital self. Ah, okay, it's capital self is the type. Yeah, got it. So that would be the same down here as well. So for player should also be self. And load standard in should also be self then. Okay, if that's better practice, we'll go with that. Nobody's actually told us that before. We've actually seen it in examples in the Rust guide, I think. I don't know if they used self, because I was just taking that from other places. We can go with that. So player has that. Player pretty much... We don't even need a new. We just did the default now. We probably don't even need this anymore. Will this be enough to initialize the default? So do I even need this anymore? Yeah, maybe the self is confusing at the start. So this can just become state now. I think. Buddha, if you're actually answering my question, Buddha, if that just becomes state, that would simplify it. And I think this is the best way to go. Let's just default initialize everything. And so we're going to do the very non-Rustful way first. So for I in 0 ... num molecule types. I'm going to say player.store. Did I call it storage or store? I like store better. Okay. That. So did you do a lot of Rust programming, Buddha? I guess you're better than I am. If you have a lot, it'd be real helpful. And so we're going to parse input 3 plus I. So I'm guessing there's a way more Rustful way to do this part here, because this looks pretty lame. player.expertise I. There must be some sort of join way to do this. Don't think that's correct. All right, we're gonna. Okay. So you guys are arguing off that. Okay, good. We're gonna compile it soon, and we can simply switch that one back. But we'll see then which one's correct, whether it's default or you have to type the name. We'll figure that one out. It doesn't bother me if it compiles incorrectly. It'll be a minor thing. But okay, we're back in expertise. This is 8 plus I. If somebody has a cleaner way of doing this, would be good without having these loops, because the loops are kind of annoying. So for each turn, we read the current state, it looks like. We read player states. And I'm actually going to do that. Read players. Read players. Again, I like clarity in this stuff. Sometimes Rust makes it a bit hard, but this one should be straightforward. Self.readPlayers. So we're still reading all this big input here. Now what's on the next line of this stuff here? What do they say is in the next line? After we've read the players, number of available molecules. Okay, ignore for this league. We're going to read them in anyways. Just to set it up, so we have, we'll say available, and these are I32 non-molecule types. Zero non-molecule types. We're going to read all the molecule types in molecule types. Self.available I equals plus I. Okay, and sample count. What is sample count? The number of samples currently in the game. Now, I don't recall reading what samples are. Sample data. Okay, so we're going to have something called sample. And carried by. So let's create our sample here. Another thing, we have a struct sample. Probably an impl sample. I don't know if we need anything yet. I just like creating these things. I mean, we'll just add the stuff here. And we'll make this one have a default as well. Derive debug, copy, clone, default. And what does a sample have? It has an ID, which I don't know, is an I32 maybe. And we're going to keep arguing about this default thing. Well, alright, so I think a consensus, if only we had a tool, if I just ran it, it would tell us what was wrong. Okay, we'll get to that. It's going to work later. So I have this sample, and the sample has a... We're going to ignore this carried by because we're actually going to stick it on each player. It's going to be really annoying. Okay, so the player is going to have samples. Yeah, I'm gonna wait off in the cargo check because we have so much sort of sitting halfway that cargo check's is gonna be distracting now. And so samples is gonna be a vec of sample. And this is actually a dynamic type here. Obviously expensive to clone and stuff then, but that's just not my problem. Okay, we don't need a carried by, we don't have a rank and a gain, but if we're going to read them in anyways, we might as well just put them in. expertise gain is a string. Wow. All right, these loops here. So Buddha, if you can, we have these loops here. We would really like to have a simple syntax here. These are fixed length arrays, so player scores a fixed length array. Okay, I'm going to keep ignoring this for now, and we're going to run cargo check later, and we're going to figure that out later. I'm going to try and just go through the structure of the code first and get this all working. So rank and experience we don't have. We have a health and a cost. So a sample has a health, I-32, and it has costs. Strange doesn't have it has a cost. Yeah, okay, fine. Cost, and this is an I-32 of num molecule types. How do I set that? I had too many things at once. Memoriam, do you know how to fix that RLS thing? Because it's still starting up. You mean in actual code settings? So you mean like here, Rust client channel stable. Yeah, Windows Scroll. That's why I'm wondering what we put here. And to me, this would make sense, but it's a weird, strange thing. And somewhere the default. I don't know. Let's just leave it, and let's just go back to it as soon as we get the compile errors. We'll figure that one out. So each sample, each player has a set of. Okay, we're going to restart the host extension and see if it restarts one more time. Otherwise, we'll let. RLS is not installed. All right, install it. It's just stable. Now it's installed. It's not starting up, it's just installed now. And so there's samples for the player, and it has a default, and each sample has a health and a cost, and we're going to read those in. Sample count. So each sample count, we have an input sample ID. This is fine. We're going to create a new sample. We're going to do this. We're going to say let's. And then I have to. Okay, let's sample equals sample, and this has an ID. Okay. We don't know about the rank and experience gain yet. Did we put a rank in? Samples only have a health and a cost. That's all we care about. I don't know about where it started. I just started it, and it seemed to find RLS and cargo and stuff. I mean, I don't know if I did anything special. We're going to have to do a mut sample here first of all, but the health, we can say health is equal to parse input this. The reason we need a mut sample is because we're going to have to do the same annoying loop again. No molecule types. Sample.cost I equals parse input 5 plus I. Okay, and who's it carried by? -1, okay, if carried by equals -1, we have to stick it somewhere else. We're just going to assume it's valid otherwise. That just seems reasonable, yeah, self.players.samples.push sample. You do? So we actually have to initialize a cost here, even though we're only a partial init. If that's true, we're probably just better off doing this. Taking the default and just overriding the stuff we do have a cargo toml. But remember, we can't add crates to it. If you're trying to think of doing it, so just do this. Let's just do it this way. Cost, we don't know. We don't care about that yet. Rank, cost was on health. Let me just sample the health. So if we had a syntax to load all these costs at once, then we could use the other syntax. But for now, we'll do it this way. And in the state, I guess the state also needs to have samples, and this is a vec of sample as well. And that's what happens when there's one self.samples.push sample. Okay, now we're going to run start. I think we got most of it done. We read the turn, and we're going to find out what happens, how many errors we get now. Not a lot, because I probably did something fundamental. So we get one error, which seems highly unlikely. And this is the whole point of RLS now, is we wanted some way to double click on here. We needed some way to actually run this in here. We don't know how. This is where we're going to require somebody to tell us how we actually get this stuff building and stuff. I tried looking for it before, run build task, fetching build tasks. Alright, while it's fetching something, let's just go do this on our own. Well, I can reopen the file. Let's do that. Let's reopen the file. Close this. RLS components installed successfully. That sounds good. I don't... Oh yeah, that's quite right. That's what I was looking for in this error. Thanks, Zaglev. You can tell I work with a lot of different languages during the day, so my syntax tends to just mix together, and I definitely rely on checks to actually figure it out because I just can't get it all right at the same time. Default cannot be derived for enums. Only structs. Well, that's weird. How do we give an enum a default then? Oh, we don't. We don't derive it. We just implement it. That's correct. I forgot to save it, or what? Alright, there we go. Did you mean state field 70 or 70, control G, 70? No. I guess I had to do something. I guess I had to give it a default. This field does not implement copy. Alright, so we'll get rid of copy for now on the sample. On the state, I mean. So we can't copy because vec doesn't allow a copy. It allows a clone. Alright, let me try to just compile this a few more times and then we'll restart it and see if it actually works. Have you tried turning it off and let's just try this first. Let's see if this is working, then we'll keep going. Once this is done, we'll restart it and... Okay, so there is no default in state. Let's just create a state. Let's create a default. Mismatched types, found reference. Oh, this is one of these annoying things. Okay, this is supposed to be to a string. Why does match not take a string? Let's see what we have here. We're going to need an index for that, though. Just remove the toString? Okay. Alright, using numerator. Well, let's go forward without that first, because I don't think it was killing us. And players.samples 131. Players does not... players carried by as usize. Got a lot of warnings which you're going to ignore for now. $76. Yes, I actually did mean a reference. And this is supposed to be /mut. That's what it is. Alright, we're going to get one of these stupid errors now. Alright, I'm reading this stuff. I just want to fix this first. Player.mut is cannot mutably borrow field of immutable binding. Why not? It's not an immutable binding. This is weird. This is the third time now that I've switched over to here and run cargo, and it seemed to pick up the older version of the file. Now, I don't doubt I can press save. I forgot to press save, but 3 times is looking a bit weird. Alright, so it actually compiles. We load stuff in, which is good. We actually load stuff in, I think. Right. So, Buddhas, you're saying this might actually look just fine for now? Well, then let's just leave this for now. I have this tab open. If we're frustrated later, we can go and play with some random thing, and yeah, it's still fetching build test. Okay, I said I'd kill this. Let's close this, and let's see if it's actually closed. See my sensors. So so code hasn't actually closed. So code is still running. Code never seems to stop, whatever it's doing. So let's kill it. Just kill code here first. And I'm going to restart code. Visual Studio Code. RLS is starting up. Does anybody think it's going to finish? No. Okay, it looks like it's broken. No, Zagyeb, we think it's actually just broken. It's whatever this RLS stuff here is doing. RLS in Visual Code has just gone, like, broken, and it's just breaking it. It was always closing before, the 100%. We just don't know what it's doing. Well, I'm sure there's all sorts of logs and stuff. I mean, I'm sure somewhere it says what it's doing. But I'm trying to just ignore it for now. I did a rust up install today. I removed rust from my system completely, and then I did a rust up install, and this is what we get. Yeah, so I'm thinking I can ignore it for now. The next time it crashes, which it looks like crashes every 20 minutes, I'm just going to ignore it, let it crash, sit crashed, and then focus more on the problem. So we have a return. Now we have to figure out what we want to do. Hey, it looks like it keeps saying stuff every time. Every time I press save, it does running save participants. That's really weird. Okay, that's fine. Now, what am I actually supposed to do? I got all this stuff loaded in, and you can open the folder? Okay, let's try that. Let's try close everything. Let's open a folder. Coding game. This is confusing. So I've opened a folder and I don't know what happened. Alright, so I apparently can't open folders anymore. It doesn't like that one bit. So that's just not working. Oh, so if I do it again, it works. Weird. Look, RLS is done now. Yay! RLS has done something! Alright, so that seems like a bit of a fault to RLS that it doesn't do that. But whatever, I'm okay with that. That's always, I hate fighting tooling. I mean, it's just like, tooling's supposed to help you, and alright, we'll see what happens here at least. We've got this running. So I'm trying to figure out, what am I supposed to do? I'm this player. I've loaded all this stuff in. Do I implement debug in this stuff? Debug. Everything has a debug. So let's try one thing first. We're going to print a debug. Print. Colon. And let's see if this actually prints state. This is supposed to have all debug. Alright, what's problems? Ooh, there's actually, that's nice. I do lots of C++ too. My compiler's written in C++, and the C++ tooling itself for C++ is, really simple, but the moment you want to use a library, every single library is different. Statement, standard format debug. What's wrong with that? I have a debug. Oh, there it is. I forgot that one. Debug. Alright. So I just want to see if we've read the stuff correctly. I just want one bit of output. Unknown wonderful. So the first thing we do is get an unknown module. So our panic works. So we had a panic. This is the first panic we have that actually works. We can clean these things up now too, since it's really easy to get to them. We don't use any of these, so let's just get rid of them. We don't know what this is for yet. Yeah, that's what I was about to do. I think we can put that in the... Can we add a string? Mod. Can we just... Oh. Module? Can we just do this? Is this going to work, or is it going to get mad at me? Yeah. How can I add two strings? Okay. So we do this. Zagilev says we do this. Perfect. Start. Unknown module start position. Well, is it lying to us? So he's nowhere to start at. Start position. Okay, start position isn't even mentioned in their thing, so their documentation's incomplete. So let's just assume start position is somewhere special. Even though they kind of lied to us then. That seems a bit unfair of them. All right. That's fine. Just show me. Oh, this is delightful here. Is there like a nice format we can have? Come on, come on. There you go. Copy that. So does this look like something reasonable? We have a player structure. We have players. They have a target start position. Let's just take the indentation so we can see the whole thing. Expertise looks okay. Samples, we have a player. Oh, that's right. I recall the multi-line one. The multi-line where every single goes on another line. Let's just look at it this way first. So we have no idea if any of this is correct, except the available. The available gives us a clue that something's correct, and the samples. Because the samples actually have ID 0, health 1, and it shows a cost. So this is the best chance we have of knowing something's right. And since this parsed correctly, we're going to assume that this is correct. So there's a whole bunch of samples in here, so we're fine. We're fine with this. So I think we parsed it correctly. So what we're going to do is just do something basic first of all. Get the basic coding working. And by that what I mean is that we'll get the we'll decide what to do. Take turn. Take turn. I don't know if this needs to be mutable yet, to be honest. It's very hard to say whether we're actually going to modify anything here. Probably are, but not yet. So we can just have a hard-coded one. Let's do a match on this. Match self dot. So let's get the player first. Let us equal and self dot player 0. I assume we're player 0. I don't know if it ever mentioned that. Maybe we are. Match us dot target. Oops. Sorry about the module. Start position. Oh, I did have it complete and I screwed it up. If we're in the start position, I'm just going to do a hard-coded one. Print line, go to diagnosis, and return. It's because we know we have to. No, we have to go to the. Which machine gives us the IDs, the samples? It's a diagnosis machine, isn't it? Yeah, diagnosis. So we know we have to go there. And if module is diagnosis, what do we want to do at diagnosis? We want to take one, and let's wrap this up into a different one. Let's do self dot. Yeah, no. It's going to start bitching at me here. Let's figure out what we do there. Module.laboratory. Molecules. I guess this is where we pick up molecules. And we're going to do the simple strategies, picking up one recipe at a time for now. We're not going to do any optimization. We're just going to pick up one at a time. And I'm trying to think of the best way to do that. If we're at the diagnosis, then we're going to check how many samples we have, and if we don't have one, we're just going to pick one up. But I'd like to wrap this all up into a different strategy here. And so I'm going to take away this mutable thing here, because it's just going to get us into trouble now. Player0.target. And actually, no. Yeah, that just do this for now. Self.step diagnosis. And we could probably get rid of all these returns here, because we're just going to do it anyways like this. We'll just pack them in this way, because it's just going to be a simple dispatch here. And what's interesting about the way this game is structured in comparison to the other ones is that we don't have to remember anything. Like in the Tron one, you actually have to remember the board. It didn't give it to you at each time. And this one it gives you the complete state each time, so we don't have to have a memory of anything. Whether we want to or not, we don't know, but... Okay, and so we're going to do each individual one. Step diagnosis. And we'll check these one at a time. And I'm going to take rid of this thing. RLS is working and contains problems. I don't know what that is. Where's our problems output? Let's just keep the problems output open. Yeah, we don't have the other ones yet. I think this is one of the reasons why I don't use a lot of these tools like this, because it tells me a lot of stuff I know, and I don't really want them on the whole time, but we'll leave it for a while. The biggest thing is it just sort of removes space from my display. Can I get rid of it now? Oh, I can get rid of it. Great. Step molecules. So we have all of them here. And in diagnosis, what we want to do is we want to say... Okay, we do a player, let us equal, and self.player0. us.samples.len equals 0. If we don't have a sample, we're going to pick up a sample. And I guess there's going to be a contention here. If the other guy also picks up a sample, I don't know how the turns work. So we're going to do print line. And what do we have to do again? We say something. What do we say? Connect ID. And we want to do, let's just assume we have a sample, and we're just going to take the first one, sample 0. If we don't have a sample, this is going to panic, and I don't know if that's a legitimate case in the game. We'll have to deal with it later. And this is the ID. And this should be enough to see us collect a sample, and well, otherwise, let's just go to the laboratory, print line, go to laboratory. Yeah, I know this is empty, but the thing is, I don't even know what to do in the game if it's empty. If we have no samples and there's nothing to collect, the game seems to be in a broken state, so I'm not going to worry about it first of all. I guess we can do this. I mean, we could say if self.samples.is empty, panic. That sounds like fun. Lost in the game. No samples to collect. We'll just assume there's always one there, so we're going to assume we never get this panic. I was going to go to the laboratory. And let's see how far we go here first. let's go back up this little screen here and see if we actually do something. We should go over to we should collect a sample and then go over here. Oops, and I did something wrong. Oh yeah, I expected, we probably already dumping out this state here. That should have been an ePrint anyways. Oh, that's what you meant. Okay, so we collect a sample and do nothing. The sample 0 is not available, which is kind of disturbing. We immediately lose. We have to figure out where ID is. So fix that first. Now we have to figure out, we loaded ID wrong or something. Sample ID. Did we really load a sample wrong? Like, how did that happen? How could we have... So Dr. Jekyll loads sample 0, and then it's no longer available. How do we know it's not... Okay, so I know what we screwed up. We screwed up when I loaded it. When we read the turn, because we're adding these samples here, we actually have to clear out all of the sample stuff. Self.read players. So each player, we're going to return it. We're going to do player.samples.clear. And down here, when we take read the turn, do self.samples.clear. And that's the reason why the sample's not there, is because we forgot to remove it from the list. So hopefully we'll pick up a sample. Go to the molecules now. And we're still trying to get 0. Okay, we return, we clear the samples, we read the players, carried by equals megas 1. Now I'm trying to figure out why our samples are not there. What have we done wrong here? Well, let's do this way. Let's print it the really ugly way. Something's gone fishy on us. Alright, so the sample 0 is not available. That's fine. What does your output have? I don't appear to have a sample 0. How did it pick up sample 0? Because it's not in the list. We can't tell because we don't have a full output. It's one of the annoying things about debugging in this game is we just don't have a full output. But if we started with sample 1, so I'm trying to figure out why we picked sample 0. Yeah, player 2 picked it up. And it's not even listed here, though. We have an ID, sample ID. So it's not in our samples thing. So if you go looking at the players, player 0 has no samples. Players 1 definitely has sample ID 0. Now the question is, why did we pick it up? It makes no sense as to how we got it here. Why on earth did we pick that up? This is our current state. It's not in the list. So it's just not in the list, but... And yet I emit it anyways. Connect 0. Well, that sucks. Let's figure out what's happening. Whatever this is, question self.samples. Let's just write out the first one. Connect 0. I know click. Okay, so the connect 0 here fails the first time. That makes sense because Dr. Jekyll took it. That's fine. But the second time, I have this list here, and I omit connect 0, even though the ID is 1. How is that possible? How can I be needing connect 0 when the ID is 1? What have I screwed up? Step diagnosis, step laboratory. We're at the diagnosis. We print line connect 0. What is going wrong? Take turn. Oh, well, we probably should get rid of this. Get rid of the hard-coded bit. That would certainly help. So it's probably just doing something wacky because I left that in. Alright, what do we have? I collect a sample and I don't know, I go somewhere weird. I should probably go to the molecules. Okay, now, so we got this, so we're getting to, we go to the molecules, and we got at least a little bit of the way there. We're still not going to the molecules, because I probably forgot to save it. Alright, so we have to start picking stuff up now. Good, so what can we do each time? We can only pick up one, and click, I think we can only pick up one. Connect type, where the type of the molecules will be transferred. Does this be collect A, B, C, or D? Probably. And how many of these do I need? Okay, so at the laboratory we're going to figure out which one we... Let's just assume we're collecting the first one first. Let us equal and self player 0. Let sample equal and us.sample 0. We shouldn't be here if we don't have a sample. So this is, our logic does not allow us to be here. And let's make this very clear. Step lost. And we do self.step lost. If we're ever somewhere we're not supposed to be, we're going to step lost instead of just kind of breaking, though we shouldn't really get there. Go to diagnosis. And so for example here, if we have if us.samples.isEmpty, we'll step lost and return. This is sort of a catch, fail, all catch. when making intelligent agents like this, panicking is really not a good idea, like throwing in type of an exception or an error. Just always try to recover, because you never know what might have happened. We could somehow, some blip in the program may end us here, so if we're just lost, let's just go back to diagnosis again. So we have this sample now, and we're going to start getting these errors right here. And, oh, this sucks. I hate this about Rust. I really do. I mean, because I borrowed it here, I can't borrow it here. Sorry, that's just not helpful. But if we do this, self.player0.samples. Yeah, well, alright, let's just assume we're not modifying it for now. See, the thing is, I strongly believe we're going to have to modify these. Or maybe not. Let's assume we don't for now. Let's just wait until we actually have to get it there. Until we actually have to modify them, let's assume we don't. And then we have to rechange all our code to work around that fact. Okay, so we have a sample now, and what we have to check is we have to check. We're going to have to do it for all of them. I mean, we'll just do it for all of them. Let's assume it's static for now. And what does a sample have? A sample has a cost for each one, and we have a store for each molecule type. So now we're just going to go through each one of these ones, and as in order, if we're missing one, we're just going to figure out which one we're missing and grab it. So, for I in 0.num molecule types, if us.store, did I say store or storage? I forgot now again. Store I is less than sample.cost I, then we're going to grab this one. Connect. It is a bit funny, we have to... Yeah, I know, I've been meaning to get to refcell, but honestly, the syntax for refcell and all that stuff looks so awful, I'm going to try and avoid it as long as I possibly can, because it just doesn't look friendly, and it looks to make ugly code from the examples I've seen so far. So I'm just going to avoid it for now. And we'll just try to do it the Rust way with not fixing it. But for games like this, we might be okay, because of the fact, as I mentioned, we're given our whole state every time, so these things may not actually need to be mutable. Okay, so what we need now is we need to say A as U8 plus I as U8 as char. I don't know if there's a simpler way to do this. If anybody knows of a simpler way to do this addition here, that'd be great, but I don't really know. Okay, we're going to return then once we've done that. Otherwise, we're going to do print line, go to laboratory. Wait, we're not, this is all meant for molecules. This is one meant for laboratory. This is all meant for molecules. And at the laboratory, what can we do? If we make a mistake, do we lose horribly, or can we just connect and try? Connect ID. Alright, so we don't have to track it. So when we're at the laboratory, let's just assume we have everything. There's no reason we'd be here for now, so let's just do this. Print line connect self.player0.sample0.id. Yeah, Windows, that's what I'm afraid of. I don't need to do concurrency yet. I wonder, has anybody confirmed whether we can create threads on Coding Game or not? That would certainly help in our scoring. That would really help. Okay, so in the laboratory, we're just going to assume we have everything and connect to the laboratory. And that molecule is going to keep collecting molecules. Let's see if we actually do something now. Let's see if we actually run this. I'm going to leave it in this small window here for now, because it gets really iffy when it goes really big. And if it actually works, maybe I'll make it bigger. I'll just make it big. So we're grabbing stuff. And I did something wrong again. Oh, I know why. That was stupid. So at the laboratory, I should have checked if I have a sample at least. So let us equal and self.player0. If us.samples.is empty. Let's do the same thing. Step lost. And that'll take us to the right person. There's losses every time, anytime we're somewhere where we didn't intend to be. Okay. So we grab a file, we collect stuff, we submit it, we go back and collect. And I always just collect the first one. We're making no obvious logic here. I'm not sure why I sit at that laboratory there. I think that's just part of the animation because he seems to sit there as well. So when we get over here, he seems to sit there. And so their bot is just set up to be stupid in this one. Basically, it looks like the Wood League is only checking that we can actually code this logic and do stuff. We don't have to have any actual ability here. We just simply code and see if we can make it by. And I'm gonna boost the speed of this here because this is gonna take a while. Let's just get this bumping up really fast. We don't see anything anymore. I mean, that's fine. But we're gonna beat him quite a bit, and all this has taken a long time. I mean, the obvious first logic here should be, let's grab the most expensive one. Alright, but does this give us enough to get by the Wood League? Let's try it. Probably because Dr. Jekyll's at the top, so let's see how well we do. Like I said, our major goal here was just to encode the logic, at least in this one. And I assume the other people are just working on their code, pressing play just like we did the first time. And there must be some dual matchups. So the initial conditions, whoever goes first must have an advantage, and that's probably why we lose in some. Like in these ones, the flip-flop is probably because whoever goes, there must be a first player, and they must have the advantage. And this person could have implemented the exact same strategy we had. And we'll see how high we get up here too, but we should be fine to get past Dr. Jekyll. So we're at 17%, but we just have to wait for this. We have to wait for a lot of battles to finish, and so we have to assume the other people here, they either just got to here, they gave up on it, or they're just playing with their logic. We did quite a few iterations first. Now keep in mind, we didn't submit as much because we're using an external editor, and I tested a lot of stuff. Didn't test it first, but we actually made our full structure first. We went through it all nice and structured. We had the cargo check. And this should get us far enough to at least pass the Wood League. And we dropped down though, so we lost against Dr. Jekyll. So we might actually need some logic. Oh man, that would suck. We might actually need some logic to make it to the next league. I was hoping we wouldn't have to. But Dr. Jekyll suddenly got a big bump here, and I'm not sure why. That's really weird. He was at like 16 and it jumped up to 19. I'm not really clear on what happened there. It looked to be like a really dumb robot, but maybe not. The obvious thing what we can do is when we go to the samples thing, we can score. We can just basically tick one that's worth more and see if that helps us or anything. I don't know for sure. But who are we losing against? Over here we're number 1, which is weird, so maybe the rankings are just weird. I don't know. The rankings might just be a bit weird, or am I getting lucky? We don't know. We'll have to see. Like I say, I just want to get to the Wood League today, and there's a few options to get there. If this simple strategy isn't enough, we can simply pick up the more valuable one. Something binged here. Don't know what. Okay, so we're going to get the promotion right away. We're better than the loss, and so we'll be promoted right away. And we'll just submit it again and see how well we do in that Wood League 1. And if we don't do very well, we're not going to do an actual strategy. We're not going to actually start doing the min-maxing today. But we'll just take the basic one to figure out. Let's just take a basic one. Let's grab the most valuable strategy and work with that. And that might imply scoring. I hope it's good enough, because if you take the actual scoring into factor, you don't want to take the one that has the biggest cost. It has to be based on the molecules, whether you can actually do it or not. Alright, great. So now we have to actually change our coding. So let's do and change that. So that might actually be enough to get past this one. And we now have a samples module. Okay, we're back to samples. Let's commit this first of all, because we actually have stuff here. Get status, get add dot, get status. Wood League 1. Okay. And what's changed? We now have a samples module. So let's go up and add the samples module. And we probably have to parse this here somewhere. Samples. And what do we have to do now? We have we just scroll. I'm not pushing that yet. I was going to actually confirm with the coding game guys first whether I should push my multiplayer stuff up or not. And if they say it's okay, then I'll push this all to a public Git. I don't have a problem with that. I just wanted to double check with them first. Now I'll check with them on a Twitter or a tweet during the week and just see if they have any problems with that or there's something wrong with it. Because again, these are their competitions. I mean, our code doesn't get us to the top anyways, right? We just passed the Wood League. If somebody wants to look, that's great. I don't think, but we'll see what happens. And I don't care about the competition either. That's fine. But I'll find that one out and see if I should publish it or not. Okay, sample data is an item. A sample data can be one, two states, undiagnosed or diagnosed. A diagnosed sample is associated with the list of molecules needed to produce the medicine in a sample. Each sample data file has a rank, 1, 2, or 3. The higher the rank, the more health points you will get from the medicine, but more molecules will be needed to produce the medicine. Alright, so I guess we know the rank first of all. Connecting to this module with connect rank, where rank is an integer between 1 and 3, will transfer an undiagnosed sample data file of rank to your robot. Okay. Okay, so we have an option here now. We can either collect undiagnosed ones, or we can simply grab the ones in the cloud. Now that's adding yet another decision criteria. So they've added all sorts of decision criteria into this thing to make it really an optimization game. And so basically we can just ignore the samples module for now. If I get that correctly, we just ignore samples and watch ourselves fail. It didn't play my code. Come on, play. Something's gone wrong. Oh, no, we never left it. We are connected to the file. You can even see the samples in the module. It's the first thing I checked. So it just didn't want to play it. That's weird. Let's just submit it. Let's see where if we just submit it. We lose everywhere. That's good to know, but why are we losing? We're failing something, so I don't think it's actually gotten our new file. Oh, there are no samples in the cloud. Okay, then they're docking. I thought there were still samples in the cloud. So Coin says there's actually no samples in the cloud. So we actually do have to change our strategy to go pick up a sample. And how do samples end up in the cloud? Can they in this version? All right, so let's just change this up a bit. If we don't have it, we're going to go to the samples module. Module samples self.step samples. We're going to have to create this as well, and this will be down here. Well, let's put it beside the diagnosis because it's very closely related. Step samples, and we're actually going to have to change the parsing a bit here too. So let's change the parsing first because we have to check if it's diagnosed or not. Carry by rank, ignore health, and wait, how do we know if it's diagnosed or not? Sample files can be one to use diagnosed or undiagnosed. So I guess if there's 0 molecules, I guess if these are all 0, if the number of molecules needed is 0, it's undiagnosed. So we'll put a helper method on that. Super slow. Implement sample, so function is diagnosed. Diagnosed is a boolean, just a bool. And I'm sure there's a map function here. And a combine. And I get really bad with these functional constructs all the time. This is more of a reduce operation. If I want to say combine all the maps and... oh, I don't know how to do that. So we'll do it the bad way. This has to be and self. Self dot cost I is greater than 0. Return true. So the moment any of them are greater than 0, otherwise we're going to return false. Because we're going to need to know this stuff, and is diagnosed. And we're going to look at the problems listing because it says it has problems here. Method is never used. Yeah, come on, give me a chance to use it. Alright, so what we're going to do is we're going to say, we're going to have to start adding logic here. Step loss should probably not go to diagnosis. Step loss should probably say, well, what are we going to do? We're going to check to see if we have let us again. Let us equals and self player 0. If us self.samples.isEmpty. Then we'll go to samples and return. That should clean that up. And step loss is going to be like the sentinel general position. This is probably going to take over as a general function step loss as the step any, because generally in any, it's not going to matter where we are. We're going to have the same general thing. What's our best option now? And where we are, it's just going to become one condition. And so we're just sort of hard coding this now as saying, well, if you're in a laboratory, do this, otherwise do that. And step loss will just help us get somewhere else. So if us.samples is diagnosed, go to molecules. Else we're going to go to, I should clean this up too so we have this proper go to function. Go to diagnosis. And actually clean this right now. Let's make a go to function. Yeah, it's not like that. The undiagnosed one have -1 health. Okay, good. Then that would simplify it. All right. Self.health. Go to, I guess, is go to a reserved word? Yeah, probably not. And let's say, what do we say? Module. Line, go to this, match mod. Mod is probably not going to like the name. Mod is not good. Keyword mod. Mod is a keyword for some reason, so let's just say mod. Anytime you see weird names in code that otherwise has proper names, just assume it conflicted with a name. Diagnosis. Laboratory is going to be laboratory. Molecules will be molecules. Samples and module. Start position. We're never going to go to start position, and I assume it's going to get bitchy at us if we actually ever go to start position. So let's assume we never go there, but okay. That should cover it. And so here now we can say go to samples. Yes, you're quite correct, Winter Squirrel. I forgot those again. And we'll clean these up here. So go to module molecules. It's actually a bit more code, but since we have the code complete now, it's a bit, I generally don't like code complete so much, but okay. So go diagnosis, go, and we'll get that. And so if we ever find ourselves at diagnosis, step samples, we never... Okay, if we're at samples, let's check. So we're going to have let us equal self.player0. If us.samples.isEmpty, else we're going to do step lost, because step lost means we shouldn't be here. Why are we here? And actually, we're going to write a connect command to connect And how do we want to connect? Though connect might be a bit harder because it's a variable type, connect. And we want a different rank, right? Rank, or what do we say? Connect at... I'd just say 3. Let's collect the most expensive one. I don't know why. Let's just collect that one. I assume we always have enough space to produce it, and there's never one that's going to be too expensive. So for empty, we grab another one. If the self that samples is panic, then we do... Now we replace this panic with step lost, because we're lost again. Why are we here? There's nothing here. Why did we come here? I'll replace this go-to with module molecules. Okay, so if we have, if us dot else, if us dot sample 0 is diagnosed, these go-to should have all been self.goto. Where's my go-to? Yeah. And self. So this RLS seems to have screwed up this type ahead thing. Rank 3 samples can cost more than 10. Oh, well that sucks. Why are they there then? They're really just there to screw with people? We'll look rank 2 then. Ah well. Yeah. I don't know how to do a static method, to be honest. Am I just going to have to type the type name instead of self then? If that's the case, I'll just leave it with self. I think I can stick with this because there's no... It's already not mutable, so there's no real reason to make it static. Well, I'll just make it self, and it's clear that's what we're stepping. Okay, so if we have an undiagnosed one, we're gonna connect here. Yeah, that's what I'd rather avoid sticking outside because there's clearly something on the state. I don't know. I might clarify that afterwards. So if we're at the diagnosis thing, I would connect with the ID of the one. So we can still connect with the ID of us.samples us.samples 0.id, whereas the self one was the actual list there. And I think this is enough for us to grab one. Okay. That should be enough to grab one. Let's see what our little robot does. And again, I put in the feature request. I wish they could just make this the size of the browser, because going full screen is really rough, but... And I'm going to turn down the speed of it now so we can see what he actually does, because we're actually just going to watch individual ones. And I apparently did something wrong. No, it's still straight. It's just not running my stuff anymore. Alright, so this is kind of broken right now, so I'm going to make sure this is saved over here. Yeah, it just looks broken. I'm going to commit it again. Safety points. And I'm just going to get out of here and refresh this thing, because it looks like it's just broken. We promoted to Wood League 1, fine, and let's join Code4Life. Let's just refresh the whole thing. That's the theme for the night, Zach. Have you tried turning it on and off again? I mean, it's coming up often. And it asked me to select a file again. It's like, that's weird. Usually it remembers it. Like, it's giving us a different name for it this time. There you have that. Now, play my code. Alright, so we're the yellow guy. We're doing stuff. We're doing expensive ones, it appears, compared to the other guy. We'll see if that pays off for us. I better put the speed up to at least 2. And doing this appears to get us quite a bit. So the rank 2 ones definitely win against Dr. Zoidberg. He's not even having a chance. So I'm guessing this gets us out of Wood League. So we still haven't actually thought of any kind of strategy. We're just doing something simple. So we can submit that. Let's see where we go with this. And so this looks good there. So again, people are probably just playing with the strategy, making it work. And I kind of like this approach to their games. Like, your Wood Leagues are basically just, have you understood the problem? Can you solve it correctly? Don't worry about the competition yet. Just worry about getting your code working. And it gives you kind of this positive feedback that, look, you got it working. You grab this stuff, it's working. Not just sort of, because if you jumped right into a legal competition, you don't want to have this situation that you get this thing working and you're like, oh man, I suck even though I got it working. I can't beat anybody. At least this way you can always beat people. And this is probably why it stops at 170 in these ones. So the moment one person gets too far ahead, when clearly the other one's broken, it just gives up on them. So people are having a bit more difficult time in this league, it appears, because we're not losing any of them. So our score should dominate. I don't think we're going to lose any of them. Which is weird. You think, or yeah, because anybody who wins here, I think, just probably goes to the next league. So the only people left in this league are people working on their algorithm. They're not actually trying to tweak anything. Hopefully we get out of this league, and I think that would probably be enough for us today for the Wood League. Just say, look, we're out of the Bronze League. Let's see how far we make it with no strategy. I mean, the strategy being pick rank 2 ones and do nothing more. We pick rank 2 and see how it goes, because like we have a substantial lead, so I guess that's all it requires. This league, all it requires is just, can you implement it correctly? And surprised they play so many games in this league, though. There's a ton of games they're playing in this league compared to, you expect them to trim it down a little bit, because there's no way you could just get lucky over this number of games, because I don't think we've lost a single one yet. Yeah, that most people just getting stuck here are basically the people, I guess they just took their code from the previous one and didn't finish it off yet. And obviously we're going to have to do some strategy here because this rank 2 and stuff, it's going to be very challenging what we actually do for the scoring. Our scoring function is going to be very challenging. How do we actually determine what is the best option to do next? And that determines a lot based on the scoring, a lot based on what the other person has. But since we have full knowledge of what the other person has, we can predict what they want to do as well. But one of the issues with min-max, and this is where min-max come from, is min-max assumes the other person has the basic same scoring knowledge. And if the other person has a different scoring algorithm, you can't actually predict what they're going to do according to min-max. So we're going to have to predict according to our own strategy and hope their strategy is, correlates well enough. So we're almost done here, but we should be just like dominating completely. So we're up to 32. And we'll get out of the Wood League. I wonder how far this gets us into the Bronze League. I can't imagine very far because we still have nothing. We've still done nothing at all. We've done the very basic state machine. We said, where are we? Where do we have to go? What should we do next? And we've done absolutely no scoring or anything. There's no multiplayer aspect to this yet. We're just basically solving the basic problem. And it gets us really high up in this one. But that's to be expected. Again, I'm guessing they don't want us to fail with an adequate code. And just waiting for it to finish. Alright, so it finished. We have to wait 3 minutes. No particular reason we have to wait 3 minutes. We just have to wait 3 minutes. So let's look at if there's anything we can do in the code in the meantime. These connects always take an ID, so that would be the next logical one, is to actually say let's put a connect in here as opposed to, where's our go-to function? Now ideally these steps would return something. If you were making a nice clear functional program, ideally these turns would actually take turn would return the next motion, say what it does. So let's actually do that. But how do we create that? We have to actually create a I don't want to create a string, or it is a string. Man, that's a bit of coding for that. So is the command to return string, because we can always have the return. Formatting a string's a pain in the ass. That's why I'm reluctant to do this. I want to make this return a string instead. The issue is I don't know how to format strings yet, to be honest. I know how to print them, but I don't know how to format them. And we could actually have a command that does it. It emits the command, or we just sit around for 3 minutes and wait till we get promoted, and then we come back to it next time and I figure out a string. So let's do this Rust format string. Because I'd like to have the functional approach, because it's not just a matter of functional, but having these emit print lines in the middle of like the code, it's just like that. It's not good. Format, yeah, format. Format is what I want. Format, okay, so it's the exact same as print, it just returns a string instead. Perfect, that's what we need. And where are we waiting? Ooh, maybe we can do that next time then. We do the format next time. Let's see how far we go on this, and because I just want to wait till the screw it. Let's just start it. And we're going to encode this code in a string, and I think it's a string. Actually, we do this return. No, this is now take this off. Take this off. Returning the encoded string is probably not the best idea, but this avoids having to create a structure that encodes the motions I can do. And so now go-to is going to be format instead. Format. And so this just becomes this. Return go-to. I guess this becomes that. And yeah, okay, Alright, so we're going to fail on this one, so science projects. Okay, so we're going to finish that next time, but let's redo this here. At least get this working where we return this stuff. And we can just get rid of this now. Okay, and we're going to return a format. So we have no way to test this change now, which is probably not the wisest idea. Right, because we can't play in that league, and we're going to fail in the next one. We really don't have a way to actually test this stuff. But this gives us a halfway step towards being more correct. And these should all be returning string. I'll fix that after format and take this off. And there are ways to clean this up more now that we're doing this. Return format. This is actually now a go-to, self.goto. No semicolon, and these are all string types. And so now what we're going to do is we're going to print line stake.take turn. Still says we have a problem right here. All right, and this is probably going to fail badly on us now because in the Bronze League we're not actually following the rules. So more than likely we're just going to fail. We're going to go over to, and it just doesn't run the code again. All right, so it's just broken again in any case. So let's just leave it there anyways, and next time, probably Thursday night, I'll come back. We'll actually tackle the Bronze League. So today we got through the Bronze League. We didn't make it very far. Well, actually, seriously, look at this. We're actually at rank 57. That's really weird. So this is really curious. We're actually at rank 57 in the Bronze League with whatever code we had in the previous one. And I find this very, very confusing because we didn't actually implement any strategy. So that doesn't make any sense. And the silly program is ignoring it again, so we're getting this debug that's not playing my new stuff. We don't know why. This clearly has the new code, it just ignores it. And the settings, we're clearly using a external editor. Well, let's turn that on and off. And it's not remembering the file, which is very weird. Something's gone wrong there. It just doesn't play the file. So I mean, we have to leave here and come back for the next day anyways. Okay, so we stopped going up. So the basic code doesn't work. We're actually going to have to start doing our coding. So we make it up to 63 here. That's going to get us some points, but we can just abandon this for now. Let's check where we are. Bronze League, and we're going to get back out of here. Alright, so the game is clearly broken now. Okay, let's go to where? Let's go back this way. And we're going to get some points for this overnight. Probably we get points overnight. I don't know if it's enough to make a big difference. I mean, just playing one game, we got to the Bronze League. It'll get a few more points here in multiplayer. And there's side time, so we should see a small uptick here. I should actually go back and fix the Tron one. This is the Tron where it's actually not stupid and it's actually working. But we'll go back to Tron at some point. But for now, for today, I think that's enough. we'll go back on Thursday to finish off Coding4Life and Bronze League, add the new rules, and we'll have to add the actual proper scoring function. That step lost function, as I said, is going to become our general scoring function. Every single turn, we're not going to do any logic based on where we are. We're just going to say, we're going to take the whole score and calculate for all the moves what is our best option at this point, what's going to give us the most points. And chances are, if we're already at some place, if you're already at the module thing, we're collecting molecules, you're best off collecting more molecules. But if there's no molecules there, then you're going to go grab a new recipe. But if at some point the molecules show up you want, you're going to go back and grab them. And so this is going to be very tricky. The scoring is very tricky. Even before we get to min-maxing, I think basically we can ignore the opponent. I'm betting we can get to at least Silver League by ignoring the opponent entirely and just having good scoring. Maybe we can get to gold. But as Euler Schitzel mentioned, the gold guy at the max, he's doing some min-maxing and he's actually considering the other player. But they're all going to be probably shoved off into the Legend League. So we might not have to do too much to get somewhere in the gold rank. But we'll figure that out next time. I thank you very much for watching. I'm going to check again in the week whether I should be uploading this code or not. And if I can, then I'll just upload it everywhere so people can take a look at it in the show. And on GitHub, I'll merge all my samples together and upload it. Again, so I thank you very much for watching. Please, again, follow, subscribe, share the episodes, retweet anything you see. It really helps out get the viewers up. And I'll be back on Thursday. It's been a lot of fun. I've had a good listen, so thank you very much for watching. See you on Thursday.